Welcome to this deep dive. Today we're looking at specs for the Kramer KDS-100EN-U, and honestly, on paper, it looks like it's trying to do the impossible.
Yeah, it's definitely making some bold promises.
Right, because it's promising professional 4K video distribution, but it wants to do it over a standard, run-of-the-mill gigabit network. And the mission here for you listening is to figure out how this device actually bridges that gap. Because usually when I hear standard network paired with high-end video, I just assume we're talking about a glitchy buffering mess.
It's a completely fair assumption. I mean, historically, if you wanted bulletproof 4K, you just ignored the IT network entirely. You ran expensive proprietary cables and built a closed-off walled garden.
Which is exactly why the KDS-100EN-U is so interesting. It's an open standard 4K AVoIP encoder, that's the official title, and it's betting everything on open standards by using H.264 and H.265 compression.
Which is really the core advantage here. You know, most AV over IP solutions lock you in. You buy a transmitter from brand A, so you have to buy the receiver from brand A. They speak a secret language.
But this Kramer unit speaks the same language as Netflix and YouTube.
Essentially, yes. And because it uses that universal language, it opens the door to actual interoperability. You aren't held hostage by one hardware ecosystem. If you want to view that stream on a software player that supports H.265, you potentially can. It democratizes the hardware layer.
Yeah, avoiding that vendor lock-in is huge. But getting back to the network side, if I'm pushing 4K video, which is 2840 by 2160 pixels at 60 hertz over a 1 gig pipe, there has to be a latency penalty.
There is a penalty, but it's surprisingly small. We're looking at about 40 milliseconds of latency.
Just 40 milliseconds, which for watching a video is basically nothing.
Right, but the critical test is the built-in KVM over IP. You can plug a keyboard and mouse into the USB-B host port and control a remote PC 3 floors down.
And at 40 milliseconds, it's fast enough that you won't want to throw the mouse across the room. The cursor actually keeps up with your hand.
It feels near instant for standard operations, and that slight trade-off means you don't need a dedicated 10 gigabit fiber ring. You deploy this on the existing copper cabling most offices already have in the walls.
That saves ripping out drywall, which is always a win. Now, there's another feature that stood out regarding network efficiency, the dual streaming. It sends a primary high-res 4K feed and a secondary lower bandwidth feed like 1080p at the same time.
Yeah, and it's really about saving bandwidth where it counts. Imagine you're recording a lecture. You definitely want the main projector showing the full, crisp 4K image.
But you only need a lightweight feed for the confidence monitor in the control booth. Or maybe for an archive recording. You definitely don't need 4K for a 10-inch monitor.
Exactly. If you forced everything to be 4K, you'd waste massive amounts of data. By splitting the stream, you optimize the traffic. It's a very IT-centric way of solving an AV problem.
And speaking of IT-centric, that is usually where AV devices hit a massive wall. You hand an AV device to a network admin, and they look at it like it's a live grenade.
Because AV gear is notoriously insecure, you get default passwords, open ports, all of that. But this Kramer unit is built with the IT department in mind. It supports 802.1x authentication.
Which, for those of you listening, acts basically like a bouncer at a club. The network challenges the device to prove its identity before it opens the port. Plus, it runs HTTPS and follows OSP 10 standards.
Right. So that has to play by corporate rules. It is a genuinely secure network endpoint. And they didn't ignore usability either. They added channel-based routing.
I love that feature. Because dealing with IP math is awful. Instead of routing complex IP addresses, you just set the encoder to channel 1 and the decoder looks for channel 1.
It masks the complexity of the IP layer for the daily user. You also get predefined deployment profiles for easy setup and PoE plus support.
Power over Ethernet. So one cable handles power and data, reducing all the clutter. It really feels like the line between AV hardware and IT hardware is completely gone with this thing.
That is the big takeaway here. This isn't just video distribution, it's data distribution that happens to be video.
It's a massive shift, and it leaves you with something provocative to think about. As professional AV hardware fully adopts these open IT standards like H.265, are we actually witnessing the end of the proprietary video matrix entirely? Are the days of the closed black box numbered? That is definitely something to mull over on your own. Thanks for joining us on this deep